All right, example 6. Verify the identity sine plus tangent over 1 plus cosine is equal to tangent of x. So looking at the two sides as far as questioning myself, which is the one that has more stuff I can do to it? Obviously the left-hand side has more stuff I can do to it. Tangent is pretty simple. All right, so I'm going to go with the left-hand side here. Sine of x plus tangent of x over 1 plus cosine of x. All right, and that's the left-hand side, LHS. So, write a little smaller so it fits better. All right. First thing I notice is there's a tangent in there. Okay, I can't make sine plus tangent any simpler than what it is. I can't make 1 plus cosine any simpler than what is. So the one thing I notice about this whole thing is tangent is in this expression. If I make that into sine over cosine from number 1, substitution sheet there, that will make the expression uglier. Uglier means there's more stuff we can do to it. All right, so that's kind of the thing is you want to kind of uglify it a little bit, and it gives us more options on what to do. So I'm going to have sine of x plus, and I'm changing tangent to sine over cosine. I'm going to put that all over 1 plus cosine. And that's going to be number 1, right? All right, by doing that, it creates a fraction inside a fraction look, so I can multiply everything right now by cosine of x. All right? Now, one thing I want to bring to your attention here is tangent of x. This is another thing you might consider when you're doing these problems. Don't write this on your paper because it's kind of cheating. If you ever did a maze, right, and you start from the start and you get stuck and then you start from the end and go back, and then it's kind of like that, but you don't want people to know that you start at the back, right? Well, you're right here. So it's kind of, if you kind of imagine sine of x over cosine of x, if you imagine, if I can make this thing look like this, then it's going to go right to that, right? So if you at least mentally have that in your mind, okay? Notice if I multiply top and bottom of this by cosine of x. Like so. I could on the bottom do cosine of x plus cosine squared of x, right? But notice I've already got part of the structure I need there by having this separated. So the same idea as the last one. If you have part of what you're looking for in your expression, don't distribute it through. All right? So that gets me on top sine of x cosine of x plus sine of x all over cosine of x times 1 plus cosine of x. All right. So the top, this isn't just sine of x, that's not just sine of x. So the top I'm going to go ahead and distribute through, do what I need to do on top, because none of the top stuff is what it needs to be, just sine of x. All right. There's some signs up there, but there's not one sign sitting there all by itself. All right. On the bottom I've got this cosine sitting all by itself, so I'm going to keep it out there instead of multiplying it through, keeping it separated, hoping that somehow this 1 plus cosine of x can disappear, doing what we need to do. And all I did there was multiply top and bottom by the same thing. M-tabst. M-tabst. There you go.
That's more efficient.
I'll buy that. If I see that you multiply top and bottom by the same thing, I think I'll figure out what your abbreviation means. Multiply top and bottom by the same thing. Make sure you put the A for and, otherwise you have no vowels and it just doesn't even look like a word at all, does it? All right, anyway. So that gets us there. And what I notice at this point is, again, I've got in my back of my mind, I want this sine of x on top, right? And the fact that I see a common factor sine of x that allows me to pull that out maybe is going to just like be glaring at me like a blinking light saying, hey, I should be factoring out sine of x. So I'm going to take a sine of x out of the top. That leaves me with cosine of x plus 1 all over cosine of x times 1 plus cosine of x. And that's factoring, factor GCF. And then what I notice is that cosine of x plus 1 and 1 plus cosine of x are equivalent, right? By the commutative property, they're allowed to be the same thing. So Those cancel, leaving me with sine over cosine. And that's by simplified. That doesn't match tangent, right? But it got us where we needed to go, right? That we knew if we got to sine over cosine, that immediately gets us to tangent by number 1 again. So notice number 1 happened a couple times in this one. One where we changed tangent to sine over cosine, the other one we changed it back. And that's allowed. You're allowed to use whatever substitutions are necessary whenever. So there is the entire identity verified. Right. So one thing again, just to highlight this, to be looking for, is to have an idea of what a expression is supposed to look like here. So when part of that expression shows up, that you're not tempted to distribute through, because again, that's a common mistake people make at this phase of trig identities. I'm going to distribute everything I ever see anytime, whenever. But again, if part of your expression is already there, keeping it isolated out, eventually you get to a point where these things match and they cancel. So again, they're all identities, they all work. So this thing has to go away, so that thing has to show up in the other part. So be patient with that kind of stuff and try to be watchful for it.